Okay, now the name of this class is Introduction to Computation and Programming. What's computation? I mean, you sort of think you know what it is, right? Probably something to do with computers or something like that. But you use the word computation in like an average sentence during the course of a day? Okay. So this title sucks. But what's really cool about this course is it's my course. What that means is I can rename the course, and that's what I'm going to do right now. So we're not going to call the course this. Instead, we're going to call the course this. Okay? That goes away. How about this? An introduction to software development using Python.
I agree.
Now the exciting part for you is people hire software developers. To the best of my knowledge, people do not hire computation people. I don't know maybe what that is actually. So we're going to be talking about software development, which is a process by which software is created. Don't you just sit down and write the software? No! Anybody here have a Xbox? PlayStation? Anything? Great, fabulous, that's wonderful. You get the new game comes out, Destiny, or Full Metal Jacket, or whatever the hell the other ones are. You go out and you get the game, right? You put the game in, and it powers up, and you go, cool, right? Now that magical game that you're playing is written in code. So somebody sat down and wrote that, right? Do you think they had an afternoon? And they sat down and they said, I'm going to write Destiny because I got a few extra hours this afternoon? Heck no! It's a team of software developers who got their act together, who had a project, who had a plan, who had requirements, who did a bunch of stuff. So we're going to open up the magical world of software development to you during this semester, which could be very practical to know, could be very useful to know. Should you ever choose to get a job? Maybe you do, maybe you don't, whatever. It's your call now. I'm not going to go down that path, but I'm going to give you the options. If you do, you'll be a little bit smarter at the end of this course. So somebody besides your parents might be willing to hire you. Sound like a fair deal? Yeah. All right, well, this is a good way to spend some time. What else we got going on here? So who am I? Well, I'm your teacher, so that's all that matters. So shut up and stop asking. No, you guys probably would better discuss about that. So I've gone to college for a really, really long time. So you guys are working on your first degree or perhaps sort of your second degree and stuff like that. Fantastic, that's wonderful. I remember working on my first degree a million years ago, and it was a lot of fun. I got a bachelor's of science degree in computer science. Had a really good time, went out and got a job. While I had a job, I said, well, I got a little bit extra time at night. I can either join a bowling league or a softball team, or else I can go back to school. Guess what I decided to do? Go back to school. That is correct, good guess. I ended up getting a master's degree in computer science. That was sort of fun. I went on, got a couple other jobs. I said, hey, I still have time at night. What should I do? Oh, I'll go back to school again. I ended up getting a PhD. Let's see, bachelor's took 4 years, master's took 5 years, and PhD I think took 4 years to get. Now, I wasn't done yet because I was working in the world of business. Business has all sorts of different words that they use and concepts they use. And I said, well, this is really neat, but I have no freaking clue what's actually going on. I should probably go get yet another college degree so I can understand how the world of business works. So I went back on an MBA in marketing. So that's 4 college degrees that I have. I've got a wall. They're all up on there. I got any more room on the wall because I can't get more degrees. Does this make me a really smart person? What this means is I'm really, really good at going to college. I am a most excellent student. I know about going to classes, taking good notes, taking tests, and passing classes. And now I'm on the other side because I'm teaching the class. Ha ha ha. I know all your secrets. All right. So when you get done with all this going to school stuff, you guys want to go out and get a job? You seem a little surprised. Are you thinking about getting a job? Just maybe kicking around? Okay, all right. Just double check. It's 8 o'clock in the morning, right? I mean, we're all struggling. I can't let you that. So I've had a whole bunch of jobs. I've actually worked for 8 separate companies. I've had a lot more jobs than 8, but I've worked for 8 separate companies. When I first got out of school, I went to work for the Boeing Corporation. I was working in the U.S. Navy's FA-18 fighter jet. Guess what I was doing? Software. Software development, that is correct. You guys are such good guessers. Very good, yes. So I was doing software development on the U.S. Navy's F-18, and I did that for about 6 years. It was a very cool job. Then I went off to Siemens. Siemens is a gigantic German company that makes pretty much everything. I worked on the part of the company that actually worked on phone switches. Phone switches, if you've ever seen a phone switch, it's huge. It looks like a mainframe computer. Potentially it takes up like a whole room, but it's the thing that handles when you dial 1, 2, 3, 4, 5. It figures out who to connect you with and all that sort of stuff like that. It's really cool. It's a computer. Guess what I did for them? There we go. Thank you very much. They went off to a little startup called Architel. Architel was a cool company. They'd actually created a layer of software. Back in the day, phone companies were buying their phone switches from one of 4 different companies. Now, each one of those switches was really cool, had a lot of great functionality, and they all had function on it like voicemail. Now, the problem that the phone companies had run into is that to set up a voicemail system on vendor A's machine required a whole particular set of commands and how you actually did it. The problem was on vendor B machine, it required a whole different set of commands on how you set up voicemail or took voicemail down or changed some sort of features on it. And the folks who run the big phone companies, Verizon, AT&T, Sprint, they were struggling because their staff had to keep getting all these big books of how to set up voicemail and remember what switch they were dealing with and do it correctly. And basically, a lot of people were ordering voicemail, but they weren't able to get it turned on quickly because it was so complicated to do. Architel had created a layer of software that made all those switches look the same. So now there was just one command to turn on voicemail, one command to change somebody's voicemail features, and all you had to do was talk to the Architel software, and then it worried about speaking the language of all the other phone switches. So it was a really cool product. It was actually very, very popular back in the day, and they did actually very well for themselves. Then I went off to work for Alcatel. Alcatel is a ginormous French company that does a little bit of everything. I worked for the portion of the company that did optical networking. So they built these things that connect with fiber underneath the ocean. So we've got to Europe and Asia and all that sort of stuff like that. Really, really cool stuff. Very, very high speed bandwidth. Then I went off and worked for a company called Santera. So that was during the .com era. Do you guys know anything about the .com? Okay, so here we go. So .com era occurred around about 2001. In 2001, you were how old? Okay, yeah, all right. So that would explain why you don't really know this. So .com era was the coolest time ever. What it was actually the internet was invented in. Wait, it hasn't always been there. No, it has not. 92. Roughly 1992 is when the internet started to become popular. Okay. By 2000, so about 8 years later, people have gone, wow, this internet thing sort of seems like it's happening, it's sort of cool. And anybody who had a business idea that they could tie to the internet could go out and go to the bankers and say, I've got the greatest idea. I'm going to set up a business so people can order pet food over the internet. I'm pretty sure that's what people want to do. And the bankers, when they heard that it was going to be an internet business, you know what they would do? Give you money! Give you lots and lots of money so you could have the stupidest idea in the world, and there was somebody out there who would give you money. That was the .com era, and it was a crazy time. It was a great time to be a software developer because there was a zillion bunch of companies who all needed software developers for their big websites and stuff like that, right? And you go into work, and they had refrigerators stocked with every monster drink you could ever possibly think of. They'd bring dinner in for you at night so that you didn't go home. You stayed at work longer and coded more and stuff like that. And they gave you stock options. What are stock options? Stock options are a little piece of the company, right? So if the company actually was successful someday, you potentially have a little truckload of money, right? So yeah, so everyone was working really hard for stock options. Really good stuff. So .com was absolutely fantastic until the party ended. The party ended in 2001. What else happened in 2001? 9/11. Yeah, so like World Trade, 9/11, all that sort of stuff. So that's sort of a sad time. But then right shortly after that sad time, the bankers said, you know, we're out of money. we're busted. And where are you at? Any of you guys going to actually start to produce money someday? And the answer pretty much across the board was no. It was fun, we enjoyed it, we had a good time, but yeah, no, we're not going to make any money. So pretty much everyone got cut off at the knees, and all those businesses went out of business. So .com was a great period of time, but it came to a crashing halt. And Santera, unfortunately, who had $200 million in venture capital funding, turned off the lights. Dang, that was only my last job. That was it. I was going to be on beaches with little drinks and have the little umbrella things. But that didn't happen. So then I went to work for Verizon. I worked for Verizon for about 10 years. Does anybody have Fios at home? We've got a couple Fios? Okay, yeah. Fios is my baby. Now, what's interesting about the Fios project is that Verizon was a 100-year-old phone company. They did a really pretty good job in making sure that you had voice service to your house. They got a B up their butt, and they decided they wanted to get into this whole, I'm going to run fiber optics out to your house and give you video. And that was a whole different set of equipment, a different set of stuff But the challenge in Verizon is that the new stuff had to work with the old stuff. And so from a software point of view, we had a whole bunch of new programs for billing and installation and maintenance and services. And we had a whole bunch of old stuff, and we had to get them to actually work together, which was really interesting because we had almost no documentation of the old stuff. It just worked. Nobody knew where it came from. Nobody knew who created it. So we spent 4 or 5 years actually getting that stuff to actually work together so it looked like it was a seamless whole. After that, I went off and worked for a company called Enlogic. Enlogic was an interesting company. They're based out of St. Louis. Enlogic made one product, but they made us power strips. You guys know what power strips are, right? You got power strips at home. That seems like a fairly boring sort of thing. However, Enlogic made power strips for one particular type of customer, data centers. The power strips that they made were probably about 4 feet tall. They had up to 44 outlets on them. In a data center, if you've ever seen a data center, what it is rack after rack after rack. And in those racks, they slide in computer after computer after computer. A fully fleshed out rack in a data center probably has about $500,000 worth of electronics shoved into it, easily. Okay? That's actually a pretty big investment. So what the Enlogic power strip did is obviously it provided power to everything there, but it also allowed you to meter on a per outlet basis. So you could tell how much each computer, how much electricity each computer was using. So if somebody started having some problems, you'd find out about that pretty quickly. It also had the ability to plug in 6 different sensors. And remember, I got $500,000 worth of equipment here, and it's off in a data center or someplace, so I can't see it, right? So if I can plug in 6 different sensors, it can tell me if there's smoke, it can tell me if somebody's gotten into that cabinet who shouldn't get into that cabinet. Probably most importantly, it can tell me if there's water in there. Just in case you're missing this, if you have electrical devices and there's water there, that's bad. That should not happen, right? So it was a really cool company. Once again, it was a startup. It was actually my 3rd startup. It was a great company until the money went away. Okay, so now I work for a company called GSL Solutions. They're based out of Tampa. GSL Solutions is a very interesting company. It's been around for about 15 years or so. They got started building websites for a very special customer, U.S. senators. So if you're a U.S. senator from Maine and you get elected, where do you go to work? You go work in... Where do you go to work if you're a U.S. senator? This is like high school...
Washington, D.C.
Yes, very good. Washington, D.C. We always have to go to the Marine guy, don't we? We always have to go to the Marine guy, yes. So you go to Washington, D.C. This is really far away from Maine, right? So the people who elected you tend to forget about you once you've gone off to D.C., right? So their websites, as a U.S. senator, is a critical way for them to stay in touch with people back home. And they're very demanding, they're very specific about what they want their website to do. So the company did very well on that. The company has started to expand into making websites for schools. So you all from high school, your high school had a website, right? Remember going to that website and all the great stuff you got off the website? Absolutely not. Most schools have websites and they suck. They're really quite bad. Okay. So there's a huge market there for GSL. I'm hoping that GSL will be my Facebook. Of course, remember, it's my 4th startup. Okay, so this is my 4th bet. So we'll see how this one works out. But I'm very optimistic at this point. One final question for you guys here. What's the difference between a job and a career? Jobs are temporary. I mean, people can work in a job their entire life if they really want to. Yeah, but pretty much these days, you'll have multiple jobs, right? All right, so what's the difference between a job and a career?
Career is something you love.
You would hope so. It sort of sucks. Well, how's that career going? No, it's really fun. No, boy, I hate it. It sucks so bad. I can't touch it. Yeah, that's probably not a requirement, but you certainly, if you're going to work on something for a while, come back.
Career is more like a path.
A path. I think that's actually a pretty good way of saying it. Yeah, exactly. So, if you're going to get some jobs, you should be working towards something, right? You should have some sort of goal in life. Right? And hopefully, personal life, work life. In your work life, you should have something that you want to achieve. You want to change the world. You want to achieve financial success. You want to run the company. It doesn't even matter whatever your personal goal is, but you should have some sort of goal. And each job that you have should move you closer to that goal. Does that sound like a fair deal? It shouldn't just be, I just need a job. Because that would sort of suck. And if so, then just go work for McDonald's. You can work any shift you want because they've got openings, right? But no, what you really should do is every job should be a stepping stone towards whatever you're trying to achieve in your career. Something straight up, huh? That is free advice. It's actually not part of COP2271C. All right, as long as we're going to be spending time together, we should have some goals. Sound like a fair deal? What would you like to accomplish? Oh, that's right. You guys weren't really sure what class you were taking. Okay, so I'll tell you what, I'll give you some goals, okay? First one, let's give you an introduction to how software is designed and created. Hey, there's more courses for you to take at this university. There's other professors who will cover it in more detail. But let's get you started correctly. Number two, let's make sure that you understand how to understand what customers want and then how to design software to do it. Seems sort of simple, right? Just go to the customer, ask them what they want, and then just do it. Duh. Problem is more often than not, customers don't know what they want. Sometimes they'll flat out lie to you. Your job as a software developer is to become smart enough to be able to have a discussion with the customer and truly understand what they want you to do. Because there would be nothing sadder in this world than having a discussion with the customer thinking that you know what they want to do, going off and spending a lot of time, energy, and effort in designing software and discovering that your software was flat off wrong, right? You think that's ever happened? Every single day. Right, exactly. So we're going to teach you how to make sure that doesn't happen. We're going to make sure that you experience the challenges of writing software programs to solve specific problems. When you write a software program, do you think it's going to be perfect every time you do it?
No.
You're going to make mistakes.
Of course.
You're going to have struggles, challenges. Things won't work out correctly the first time. Is that correct?
Yeah.
You're anticipating that going into this class?
Of course.
How incredibly depressing. Whatever. I mean, if you want to be all sad like that, then that's fine. But yes, you will run into challenges, so let's talk about those challenges. Let's see what kind of things you're going to bump into. Let's kind of find out what kind of challenges you're going to have. And let's going to find out how you're going to work through it, right? Software developers everywhere have challenges. When they write their code the first time, generally it doesn't work. Or if it works incorrectly. So you have to be able to detect that it's not working. You have to be able to figure out what's going wrong, and then you have to be able to fix it, right? These are basic sort of software development tasks. In this class, you will be doing those things. We will teach you those skills. What's the last thing? Oh, learn the Python computer language. On this list of 4 things that we want to accomplish in this class, learn Python is located where in the list? Right? So we're going to be learning the Python language. But Python is just one language. Are there other languages? Heck yeah! C, C++, C#, Java, JavaScript, Agile, Fortran, COBOL, Pascal. I mean, there's a zillion different languages, right? Every language was developed for a very specific purpose. Okay? Certain languages are good for certain tasks, depending on what you're doing. We're going to learn one particular language during this particular class, and the whole purpose of that is to teach you what a computer language looks like. Once you know Python, it will become much easier for you to learn any other computer language, because you'll be comparing it to Python. You'll be like, oh yeah, I recognize it. Oh, that's very similar. Yeah, I've seen that before. Boom, 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 right? So different languages require, different problems require different languages. This is just one of them. Learning Python is not that terribly important. In my book, learning how to do software development is, but Python's like a tool, so we'll learn how to use the tool. How are you going to accomplish these goals? It's a bunch of things have to come together. You need to understand how to design software. You're going to have the tools to actually design the software. You have to do a little bit of project management to actually get the stuff done. And of course, you have to have the professional skills to pull it off. Your mission, should you choose to accept it, is going to be to understand what customers actually want you to do. Okay? You're going to have to create a design that can be coded. If you create a design that can't be coded, congratulations, that's fantastic. You're not going to do anything good, right? Then you actually have to code a solution. Then you have to test your solution to make sure it actually does what it's supposed to do. And finally, you have to package your solution to deliver. Make sure that you have something that the customer actually wants in the end. Does that sound like a fair deal? All right. How long is the semester? That's a good question. How long is the semester? So here's the thing. I'm a very visual guy. I just sort of need to see a picture of the semester to get my hands on it. So we are here on the 7th. On the 25th of February, you will be having a midterm. That's sort of sad. Sorry about that. But immediately after the midterm, you get spring break. How cool is that? Quick question. So we're in Florida. Where do you guys go for spring break? Home? You go home? You just spend a week at home? That's so sad. I went to school up north. We always went to Florida. It was football. You go skiing or something? Like, let's go find some place that's cold. It seems like sort of you're handicapped somehow. I don't know, whatever. Great. After spring break, we come back for the rest of the month. We do a little bit more work in April, and then bam, sometime on either the 27th or the 29th, you have a final. And with a little hope, you pass this little hope. Keeping some fingers crossed, you passed this class. Sound like a good way to spend the semester? So we're going to have 28 classes. That's 14 weeks times 2 classes per week times 1.8 hours. It comes out to be a grand total of 50.4 hours that we're going to spend together. That's a long time, isn't it? That's like over a day. Oh, geez. All right. So during that 50.4 hours, there's going to be a bunch of stuff. By the way, there's something called Canvas. You guys know about Canvas? Some sort of system. I guess if I ever get access to Canvas, which I think I'll get in like the next week or two, I can put these notes on Canvas, and then you can get them. That sound like a fair deal? Okay, step 1, I have to get access to Canvas. Step 2, I actually have to put stuff up there. But that is my plan. So here's a bunch of stuff, and this is actually, I'll come up with the syllabus. I'll make sure you guys get a copy of the syllabus. But we're going to have a bunch of homeworks, probably about 4 homeworks. You're going to have a midterm about here. You'll have a screen break about there, a little bit more homework. I'm a big advocate of in-class presentations. So software development, is it done by yourself or is it done as part of a team? Team. It is. Now, teams suck. Teams really suck. Man, if you could just do it by yourself, it would be so much easier. But the reality of the world is generally the projects that you work on are so large, they have to be done by team, right? So the sooner you get used to working in teams, the better it is for you. And I'm going to be interested in having you guys do in-class presentations, because guess what you do in the real world? You do work and then you tell people about it. So that's what we're going to give you chances to practice. All right? And trust me, you won't go up in flames or anything else. It happens once in a while, but generally probably not in this class. And then poof, we have a final exam when we're done. Oh, did I skip something? How am I going to organize the class? All right, so we're together twice a week for 2 hours. 2 hours. At 8 o'clock in the morning, who came up with that? I have no idea. All right, so I'm going to divide the class up into 2 parts. The very first part of the class, we're going to talk about software development. It's actually the process of creating software. So what's that? That's requirements, that's debugging, that's packaging. It's all this stuff that has to do with programming without actually talking about programming itself, right? If you ever get a job as a software developer, that's the stuff you're going to be doing. That's the wrapper that goes around the job, okay? After we get done talking about that, we're going to take a tiny little break for about 15 minutes or so. Stretch your legs, get some coffee, have a smoke, get your butt back in the room after 15 minutes. I promise to you that when I start the second session, the stuff that's going to be on the test, I will cover right off the bat in the second session. I do that just very, very neat. So come back whenever you damn well please. I don't really care. But all the good stuff, I cover right off the bat. So there you go. The second part of the class we're going to spend talking about specifically the Python programming language. Best analogy I've been able to come up with so far. So Python is sort of like talking about saws. So we can spend a whole semester talking about saws. There's big saws, and there's little saws, and there's power saws, and there's saws for different types of wood, probably. I don't know if you're a saw guy, but it would assume that there's a world of saws. We can spend a whole semester talking about saws. At the end of the semester, man, you would be really smart when it came to these saws, right? But if you really wanted to be a carpenter, that wouldn't really help you a lot, right? Hey, build me a chair. Well, I've got a saw. Well, that's fantastic. That's not going to do me a lot of good. So software development is sort of talking about being a carpenter. How to build chairs, how to build tables, how to build stuff out of wood. Now, to do that, do you need a saw? You always need a saw. You always need a saw for a carpenter. You can't just toss a piece of wood and say, okay, transform yourself, like you can in some movies. They're not in real life. Okay, a little more than that. So as a carpenter, you need a saw. Well, that's cool. That's why we'll talk about Python. But we'll also talk about being a carpenter. So you're sort of getting 2 for 1 in this class. That sound like a bonus? Sound like an idea? Okay. Sort of understand the organization of what we're trying to pull off here. Okay. Why show up for each one of my classes? Well, first off, because I take attendance. Okay, so that'd be sort of important. And it is a portion of your grade. You don't show up, I will know about it. I don't think darn. But also, hey, is everybody in state? Do we have any out of state? Any out of state? Okay, so in state folks, at this university you pay $183 per credit hour. This is a 3 credit hour course, which means you're paying somebody is paying $550 for you to have your butt in this particular class. Okay? If you blow off a class, each class is worth roughly about 20 bucks. So some morning, you're like really sleepy. I'm like, last night was so late. And you're like, wow, should I really get up and go to Dr. Anderson's class? And you go, I just so cannot make it. I don't think I have to go. I will go later on this week, not today. Fine, sleep in, have a great time. But when you finally wake up, what you need to do is go down to Starbucks. You need to purchase 6 cafe mochas and then go throw them in the trash can, because that's effectively what you just did. And meanwhile, I will have taken attendance. I will have known that you did not show up for my class, and I will be thinking dark, dark thoughts about you all day long. Is that clear? Got it? Okay. I'm watching you. I am watching you. All right, how's your grade going to be determined? This could be a little better if there's like lines and stuff like that. But the way it works is basically final, midterm, fourth homework, third homework, the other two homeworks, participation and attendance. So everything counts. So if at the end of the semester I don't know who you are, you've got a little bit of a problem because you didn't participate. Got it? So you gotta answer questions, put your hand up, ask questions, stuff like that. Make sure that you know that I was here in a positive way. Okay? All right. What are we going to accomplish in 50.4 hours? Well, I'm going to help you become a software developer. It's going to take 4 years for you to get your act together on that, but we'll at least start you on the path. We're going to make sure that you understand professional software design. How do they actually build that software? Okay? And I'm going to provide some guidance for executing design projects. You know, hey, so here's what you have to do, and here's how the software pops out on the other end. Let's make sure you understand how that process works out. On the bottom here, I have some sort of famous engineers. Ray Dolby. You guys know who Dolby is, right? You probably purchased some of his products. What does he make? He makes sound systems. Back in the day, it was cassettes, but you also see it in theaters. Okay. Hyman Rickover, you may or may not know, but Hyman Rickover was the guy who sole responsibility for the atomic navy. So he's the guy who came up with the idea for atomic submarines and atomic battleships and stuff like that. Steve Wozniak, who's he?
He was with Steve Jobs making Apple.
Yeah. He made the Apple. Jobs was like just the front guy who got and sell the Apple. But Woz is the guy who actually came up with it. He was the guy, the engineer, the designer. He's a very cool guy. And Melissa Meyer, do we know who she is? Nobody knows. Okay. Melissa started out at Google, did very well there. She was a product manager. She's now the CEO of Yahoo. And she's probably the most photographed person in IT just because she's attractive. And so there you go. But anyway, so all these people have done very, very well for themselves. There's absolutely no reason why you can't do just as well for yourself as these people have done. But it all starts in COP2271. All right, book for the class. This is the book for the class. So here's the scoop on the book. It's a good book. It's a fine book. Is it a special book? No, not really. Okay. You don't have to get this book. You probably should get a book on Python. It's going to be a very helpful reference for you. You don't necessarily have to get this particular book. I will not be using the book in class. I will not be assigning homework problems from the book or anything like that. You don't have to bring the book to class. Okay? But you probably do need some sort of reference material for Python, the language. So keep your eyes open, find something that works for you. You can get this one. It's a very good book. There's no problem with that, but you could also get something else that might have a lower price. Okay? What is a software engineer? Well, if you want to grow up to be a software engineer, sometimes we should at least have an agreement as to what a software engineer is, right? A lot of different ways to define it. I like this one down here. One who employs the innovative and methodical application of scientific knowledge and technology to produce a device, system, or process which is intended to satisfy human needs. Basically, somebody who listens to people who have problems and then creates a solution to it. Doesn't get a lot simpler than that, right? So do software engineers make people happy? I don't think so. Isn't that the coolest job in the world to have? You make people happy. I think that's just absolutely beautiful. That's fantastic. All right. So let's talk about creating a software program. And the reason we're going to have this discussion is because I'm going to try to teach you a different way of thinking about life. So in the morning, it's entirely possible that your mother, your father, or some important person in your life throws open the door to your bedroom, flips on the light, says it's Monday, Wednesday, whatever, it's 6 o'clock or 7 o'clock in the morning, you've got Dr. Anderson's class to go off to. Get out of bed and go to school. When they did that, what would you do? What should you do? Get out of bed and go to school, right? And we all know what that means. Is that correct? Mom, Dad tells us to get out of bed and go to school. We know exactly what they mean. And we do it. Well, you better be doing it. Otherwise, you're going to be having a long talk later. Okay, anyway. So we're cool with that, right? Now, put on your software developer hat. It can be a cap, it can be a hat, it can be a stylish beanie, it can be whatever it is. Put the hat on. So when you hear your customer say, get out of bed and go to school, what should run through your mind is, step one, get out of bed. Physically get yourself out of bed, okay? Step 2, if you're like 98% of humanity, you go to the bathroom. Thank you very much. Number 2, you're going to go off to the kitchen. 3, you're going to go off to the kitchen. Number 4, you're going to have to acquire the supplies that you need to have for breakfast. Cereal bowl, cereal, milk, OJ, spoon, and banana. Is that like having breakfast? No. You've just built or collected all the things that you need for breakfast, right? Next thing you do, you place the cereal in the bowl, you pour some milk on it, and you peel the banana. Is that having breakfast? No. Now you've prepared breakfast, right? Okay. Next thing you're going to do is you're going to sit down at the table, because nobody eats breakfast standing in the kitchen. That would be ridiculous, okay? Next, eat your breakfast, okay? Interesting enough, does it matter what sequence you eat your breakfast in? I don't think so. Can the banana go in first? Could you do half a banana, bowl of cereal, half of a banana? Does it matter? Oh my God! Look, we've had an innovative breakthrough. You're exactly correct. A lot of people do that, don't they? Yeah. All right. You could also cut the banana longwise. Oh, chop it. Okay. It doesn't really matter. Oh, if it mattered, we should talk about it, right? But if it doesn't matter, we can sort of skip over it. Now you go back to your room. You take a shower. You get dressed. Getting dressed includes socks, shirt, pants, and shoes. Could we have a much longer talk about this getting dressed thing? Because first off, look, there's a decision about what you're going to wear today. Is it clean or is it dirty? Is it like really dirty or just sort of dirty? Okay. Are we going to match what we're going to wear, or are we just going to say, I don't really give a damn, right? Okay. Now, there's jewelries, there's accessories, there's facial piercings. I mean, my God, the decisions are almost limitless. We could, but I only had too much room, so we're just going to assume getting dressed is just like that. Grab your backpack, your laptop, and your cell phone, shut and lock the door, bam! Would you agree with me that this is effectively the same thing as this? Right? But you had to, when you were told this, you had to process and break it up into this. Is that correct? That's software development right there. Your customer gives you a requirement, and you go, that means I have to do all of this. Right? And in the customer's mind, it's just get up and go. Meanwhile, you realize that there's a lot more going on behind the scenes. And that is what computer programming is all about. Okay? So I'm trying to get your mind to start to view problems like this. When you get told to do something, you start processing in your mind, how would I actually go about doing that? All right, that was good. So now let's do one together. Make a sandwich. How are you going to do that?
Find out what kind of sandwich?
Ah, look at that. We've got the smartest man in the room in the back corner. Very good. Congratulations. I would like you to make me a PB&J without the crust.
What kind of jelly?
What's that?
I'll show you the bread.
Well, that's true, but, and that's the interesting question, right? What kind of bread? I would like it to be on white bread.
What kind of jelly?
What's that?
What kind of jelly?
Jelly? Okay, I'd like to have strawberry jelly. Now there's going to be another question. I want crunchy! There we go. All right. Are there any other decisions to make here? Okay, so where are you going to go?
The farm.
Let's assume you have all the items. Where are you going to go?
Kitchen.
Kitchen! Fabulous, you're in the kitchen. Now what are you going to do in the kitchen?
Wash your hands.
What are we going to do?
Wash your hands.
Thank God. Have you ever worked in food service?
Yes.
Because that was the right answer. All employees must wash hands before returning to guests. You've got good one. All right, great. So we wash our hands. We're all clean. Thank you very much. Now what are we going to do? Okay, get the bread. Poof. Okay, I got the bread. Now what am I going to do? Peanut butter, jelly, knife. How many knives? Two knives? Okay, whatever. Does this one know? Would they actually know? Okay, anyway, well, we care.
I do.
I say, you don't have that jelly or gift card, I know. Okay, anything else? So we got 4 things. I think we're missing something. So we have bread, jelly, peanut butter, knives,
Plate.
plate. Okay, we'll go with that. Okay, plate, fabulous. Okay, now I think I have everything I need. I'm making a sandwich. What do I do now? Now, here's an interesting question. You know loaf of bread? You know it's got that end piece? Do we skip the end piece and go for like something on the center and then put the center piece back? I don't really want the end piece. I guess I should cook that. Make a sandwich without using end pieces. Okay? So you're going to take out 2 pieces of bread, right? Bam! I've got 2 pieces of bread. Now what?
Take off the crust.
Interesting point. So you said take off the crust. So I'm going to cut the crust off one, and then I'm going to cut the crust off the other one. See? All right, we have a fundamental conflict here. Do I make the sandwich and cut the crust off? Or do I cut the crust off and make the sandwich? And if I'm going to cut the crust off before I make the sandwich, do I cut it off each piece of bread, or do I stack them on top of each other and then chop off the crust, and then I have 2 pieces of bread that I can make sandwiches? Are there 3 different ways I can do this?
Yes.
Is any one of them better than the other?
Yes.
Am I getting any performance improvement? Am I cutting down on my preparation time? Okay, but we'll grant that there's 3 different ways to do it, right? Actually, this is actually a fairly important point from software development. All right, so creating code, I personally view as almost being like a work of art. So what do artists do? They use watercolors, they use oil paints, they use clay, they use stone, perhaps they even use words, like write a novel or something like that, right? Well, in the world of software development, you use basically the limited vocabulary of whatever the computer language you have. Now, the way you write a program to solve a problem is potentially different from the way I would write a program to solve it. Does it make yours right? No. Does it make mine right? No. Mine might be quicker, better, faster, but if yours produces the same answer, and your customer doesn't care about speed or execution, it doesn't really much matter, right? Yours may be more elegant and more easy to maintain, which ultimately over time may really matter and stuff like that. But this whole sandwich, crust off now, crust off later, you go either way, it probably doesn't matter that much, right? But you're going to end up with a sandwich, right? But that's the key thing to understand from a software development point of view. The way you create your code will be different than the way I create my code, but it probably doesn't matter. It's just your individualistic way of looking at the problem. And that's completely cool, because it's sort of a work of art that you're creating. It has to work. Mona Lisa just has to hang on the wall. Your code actually has to produce the right output, right? All right, so this gentleman says we should cut off the crust. I'm hearing a general consensus. Should we cut off the crust after we make the sandwich?
Yeah.
Okay, all right, so your idea was fine. No problems with that whatsoever. We're going to do the other. Okay, great. So I've got my bread sitting here. Now what? What do I do? It still has its crust on it. So now what do I do? Next step? What am I starting with? Am I doing peanut butter or jelly first? No, not my call. Your damn call. You're making my damn sandwich. So you come back out to my table and say, sir, we're making a sandwich. Peanut butter or jelly first? Which one should we? No, don't.
Open the jars first.
Okay, jars are now open. Great, now what?
Peanut butter.
Peanut butter? Okay, great. So I'm spreading out my peanut butter with my knife. Then I take that knife and I stick it in the...
We have these multiple
We
knives.
do have multiple knives, so now I put that knife down.
Put that on the sink and
And then get the other one.
Or you get a rinse out.
So what's my next step? After I spread my peanut butter on what do I do after I spread my peanut butter? Jelly on the other piece of bread. I don't just put it on the other side of the same piece of bread?
No.
Okay, so 2 pieces of bread, one has peanut butter and one has jelly on it. Is that correct?
It depends on your style.
I'm sorry, what?
It depends on your style. Some people like peanut butter on both sides and then put the jelly on top of the peanut butter.
Peanut butter on both sides of a piece of bread.
Yes.
No, not on one piece, but
Okay.
like on 2 separate pieces.
Okay, well, no, I actually bring up an interesting point, right? Because arguably I could put peanut butter on both of them, and I could actually put jelly on both of them. It's like double peanut butter, double jelly, right? It's a sloppy sandwich when you get done with it. And there's an interesting question that you guys didn't even discuss, right? So jelly is actually a fairly wet type of thing, right? And I'm putting it on bread. So depending on how long it's going to be sitting around, that jelly can sort of seep through, right?
Oh, that's like
If I
peanut
put a
butter.
layer of peanut butter on it first, would it seal the bread? And then I can put the jelly. You know, so what? Interesting design issues. Okay, but okay. Anyway, so I've got 2 pieces of bread. One's got peanut butter, one's got jelly on it. This is fantastic. But this is not a sandwich. Now what do I do? Now, is there anything about putting them together? Do I have to do it horizontally? Should I do it vertically?
Doesn't matter.
Doesn't matter?
As long as the peanut butter touches the jelly.
Okay, peanut butter actually has to touch the jelly, so that's our requirement. Should I do it fast or slow?
That's probably the best way.
I mean, is it going to stick together better if I do it fast? You know, do I need to leave fingerprints, basically, to get it? Great, so I put the sandwich in there. Now.
Deliver it to the crust.
Don't you delivering it because there's still something else to be done. Look at the sandwich. What do you see? We got crust problems, right? So what do I got to do? How do I cut the crust off? Is it a continuous?
No.
Or is it a chop, 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 chop? Okay. How am I doing this? Is it 4 chops or 1 big one?
4 chops.
Do you think 4 chops is probably the best way to do it? So if I took out, great. Now I've got my chopped sandwich. It's sitting there out in my kitchen. What do I do now?
You want to cut it in half?
You know, that's a good point. You didn't ask me, did you? I'd like to have it cut diagonal. All right, so you cut it diagonal. Bam. Now what are you going to do? Put it on the plate circularly, right? Bam.
Forgetting that.
Where was it before it was on the plate?
Damn! Making a sandwich is a big effort, isn't it? So make me a sandwich is simple to ask, right? But when it comes down to the nuts and bolts, first off, I didn't give you enough information, did I? There was like, what, 6 or 7 other things that you had to ask me during the whole process to figure out what the heck I really wanted you to make me, right? So then that's the key thing with requirements. Customer often doesn't really realize what they haven't told you. So it's going to be your responsibility to find out. Because you don't want to create a sandwich that they don't want, right? Yeah, take it back. Could I have been real clear about it? Mmm, tasty. I wanted peanut butter and jelly. Damn it. All right. Software engineering. Well, software engineering basically breaks down into 5 steps. And we can talk about it for an entire semester, and we probably will. But just at a very, very high level, there's a concept of requirements. What does your customer actually want you to do? Let's be really, really clear about that, okay? Next thing is specification development. This is actually sort of a key issue. So in most organizations, there's somebody who talks to the customers and says, what do you really want? And then transforms what the customer says into the language that the software developers speak, basically internal requirements. And I got news for you. You know, software developers do get paid good money. There's no question about that whatsoever. The people who turn customer requests into actual actionable things for the developers to do get paid more money. And the reason is that I go to India and I get software developers to work on my project for roughly about $10 an hour, very easily. It's hard to get somebody who can talk to customers and transform customer requirements into developer requirements. There's not as many of those people floating around who can do that well. Software design is exactly what it sounds like. Okay, great, here are the requirements, so what does my software need to look like? What does it have to do? And then I actually have to create the software after I've designed it. Then, of course, test and verification. I got to make sure that the thing actually does what it's supposed to do. And finally, maintenance. Interesting thing about software. In the real world, creating software is very, very similar to having a baby. It's a lot of fun to create. Yay! But once it's created, guess what? It's there forever. Or until it gets replaced with something else, which generally takes years, right? But what happens is after you create the software, the customer comes back to you and says, hey, that's great. You know what else I would like it to do? You know what else I'd like it to do? You know what else I'd like it to do? And so what you do is you keep going back to the code that you wrote and adding or changing what it does. And arguably, that's an easy 80 to 90% of software development. Working on stuff that already exists. But it gets a little bit better. If a company hires you as a software developer, guess what they're going to do on day one? Give you somebody else's code and say change it. You're like, oh wow. Hope they did a good job documenting their code. Hope they weren't a crazy coder. All my variables start with X. Just because I like X. Just so they're Alright. Alright, so what did we cover today during this portion of our class? Well, first off, we renamed the class. Yay! That was fun. We identified the goals of the class. That seemed like a good thing to do. Got you to agree to show up for every single... I'm sorry, did I get you to agree to show up?
Yeah.
This is a really good time for you to know. This is a good time for you to know. Okay, that's right. Okay, good. And then we finally figured out what software engineer is. All right, that sounds like a pretty good way to spend some time. What are we going to do next time? Next time we're going to cover the 2 primary concerns of software projects. We're going to talk about 3 things that great software development delivers, and we'll talk about something called iterations. That sounds like that's pretty interesting. Fantastic. Second part of the class is going to be this. So you've got 15 minutes. Go amuse yourself. Come back in 15 minutes, which should be probably about 5 after. Okay, and I'll cover all the important stuff right off the bat. Thank you very much.